evidence. But until this problem was discovered, people thought that at long last they had identified a particular social cognitive module in the brain. Canwisher, there's a quote from Canwisher, a cognitive function, face recognition, with its own private piece of real estate in the brain. Okay, there's this piece of the brain that does nothing else except recognize faces. And the question is, how good is that evidence? I'm going to try to argue that that evidence is actually not very good, but the point of this is not that Canwisher is wrong and I'm right or somebody else is right. That's not the point. The point is that if you're going to identify an area as a task-specific module, you've got to do the experiment correctly, okay? And the experiments have not always been done correctly. So, for example, here's how prosopagnosia often gets assessed. You present a picture of a person and you say, who is this? And normal people, all of you recognize this is President Obama, and you present a picture of, say, a house and you say, what is this? And everybody in the room is going to say, that's a house, okay? That is how the face-specific deficit in prosopagnosia was first identified clinically. But if you think about it for a second, and nobody did until very recently, these are two very, very different kinds of questions. To present a picture like this and say, what is this, is a question that addresses what's known as the basic object level of categorization. You can say, it's a house, and you're right, okay? But if you present a picture like this and you say, who is this, that is not a question that addresses the basic level of object categorization. That is a question that addresses what's known as a subordinate level of object categorization, where you have to classify an object as a particular instance of a category. So, who is this? Okay, that's President Obama. What's this? It's a house. Okay, this is a definite person. This is an abstract thing. A fairer comparison in these kinds of studies would be to say, who's this? It's President Obama. And what's this? It's not just a building. It's the White House. Okay, it's a specific subordinate level category member. The usual demonstrations in both prosopagnosia and in brain imaging studies of the fusiform area have confounded these two levels of categorization. When people are asked about faces, they're asked to identify individuals. When people are asked about non-faces, they're asked to identify a broader, abstract, basic level category. That is a fundamental confound in this literature that nobody had ever noticed before, until a graduate student, in fact, Isabelle Gautier, now at Vanderbilt University, was reading this literature and said, gee, wait a minute. Think about this for a second. She stumbled on this, and in fact went off to do a couple of imaging experiments of her own, and argued and discovered that if you ask a question about is an object a bird, okay, you don't activate this area of the fusiform gyrus. But if you ask a question about the object at a subordinate level of categorization, like is it a pelican, you do. Okay, so questions directed at a subordinate level of categorization activate the fusiform area, regardless of whether it's a question about a face or a question about a non-face. This is the first hint that the fusiform area is not, in fact, dedicated to face perception, but rather seems to be dedicated to subordinate level categorization, of which face recognition is only the easiest and most common example. Yes? Yes, this is all the stimuli in these experiments are visual. It would be very interesting if you could actually find a voice recognition area in the brain. Exactly the same question would come up. It's hard to imagine just off the top of my head what that experiment would look like, but I guess you present, say, President Obama's voice. Whose voice is this? And then instead of playing just a piece of music and asking what is this, it's a piece of music, it would be a piece of music and it would have to be, it's Beethoven's Fifth Symphony, or it's Mozart's Eine kleine Nachtmusik, or something like that. That would actually ask you to identify a specific non-social piece of music in the same way that you're asking to identify a specific voice. That's how you'd have to do the experiment. That's exactly right. Yeah. My understanding is that they don't have any difficulty recognizing that as a face, okay? Although what they have of course, those schematic faces aren't particular faces, right? What they have difficulty doing is recognizing particular faces, okay? And in fact, there's a case study of a prosopagnosic French dairy farmer who couldn't identify specific cows either, whereas many dairy farmers can, in fact, identify specific cows. He lost that ability as well. Of course, cows have faces, so it's not exactly clear what to make of that. Let me go on here. Yes, quick. Yeah, they would have difficulty recognizing Little Abner because that's a specific individual. They'd have difficulty recognizing Mike Doonesbury. They'd have difficulty recognizing Mallard the duck in exactly the same way. Now, I'm not sure that's been put to any formal experimental test, but that's what they would have difficulty doing. They say, oh, it's a cartoon character. Okay, that's no problem, because it is a cartoon character. But to identify the specific cartoon character, they'd have problem doing that. Yeah, but it's not a matter of ease of recognizing. It's a matter of connecting a specific face to a specific name. So the problem that these individuals have is at the subordinate level of categorization. I suppose, you know, if you're not very badly prosopagnosic, if you made the task really easy, they could do that. But in general, what they have difficulty doing is identifying specific faces as belonging to specific people. Let me go on here, okay? Because we can now pursue this a little bit. Gautier and her then advisor, Mike Tarr, began to say, well, okay, let's look at this further. They identified a number of people who were experts in identifying cars. Can look at a car and say it's a 1963 Chevy Corvair, you know, in a way that most of us probably can do. Or people who are really good at identifying birds. There are lots of those people out there. They also brought people into the laboratory who had absolutely no expertise on various kinds of things and taught them to identify snowflakes. Yes, every snowflake is different, but snowflakes actually fall into one of about 9 categories. So you can learn to categorize snowflakes. And they taught people to identify fingerprints. Every fingerprint's different, but there are various families that fingerprints belong in. Tarr constructed these objects known as greebles, which are three-dimensional solid figures that, again, can be classified into families by virtue of various configurations of features. They're not very face-like. And what happened was, when experts classify cars, when car experts classify cars, when bird experts classify birds, the fusiform face area lights up. When people are trained to classify greebles or snowflakes or fingerprints, in early stages of training, when they're novices, the fusiform area doesn't light up when they classify these objects. But as they become expert, and these people were trained for dozens, hundreds of hours in order to become experts, as they became expert, the fusiform area began to be activated when they classified those objects. Here is a good example of this. You've got this is an area of the brain, this is the fusiform area right there, that's activated when people classify faces versus just ordinary objects. Same area being activated when car experts classify cars, and the same area being activated when bird experts classify birds. Notice that there's no activation when car experts classify birds, and there's no activation when bird experts classify cars. But there is activation when bird experts classify birds and car experts classify cars, and everybody's an expert at classifying faces. Okay? So you can see what's happening here. Here's some more examples of these greebles. They're favorite stimuli by people. But again, greeble novices don't activate the fusiform area when they classify greebles. They do activate the fusiform area when they classify faces, but when they become experts in classifying greebles, the same area that is activated when they classify faces is activated when they classify greebles. Okay? And the same thing happens with snowflakes. Just take my word for it. Suggesting to Gautier and Tarr that the function of the fusiform gyrus has been misapprehended, okay, by virtue of the fact that investigators failed to eliminate this confound between levels of categorization. In the typical experiment on the face area, the faces the face stimuli have to be classified at subordinate levels of classification, but the non-face stimuli are allowed to be classified at basic levels of categorization. If you force subjects to use the subordinate level, you see the fusiform area lighting up in both instances. Yes? All right, it would be really nice if people could attach individual names to individual greebles. Okay, yeah, that's a completely fair statement. But you can see where this is going, right? They're all involving subordinate levels of categorization. The fact, let's go back here for a second. The fact that the fusiform area lights up when greeble experts just are identifying that what the level of looks like a college professor, you know, or looks like a middle-aged man or something like that. That's still a subordinate level of categorization, and it's still activating this fusiform area. So you can't get away from the fact that there are non-face stimuli that are activating the same area that the face stimuli are activating, which suggests that the fusiform area is not specifically dedicated to faces after all. Now, the jury's not completely out on this yet, but we're building a story. Here's the story as of about 10 to 12 years ago, which is that what Tarr and Gautier argued was that the fusiform area performs subordinate level object categorization regardless of what the stimulus is, okay, whether it's faces or non-faces. And there are a couple of ways you can think about this. For example, you could think about, the way traditionally we've learned to think about this, that the fusiform area is dedicated to face identification. It's a specific piece of real estate that performs a particular kind of task. Gautier and Tarr argue that what is really happening here is that the fusiform area is more flexible than that. Yes, it's dedicated to recognizing faces, but it's dedicated to more than simple face recognition. What it's really dedicated to is subordinate classification, subordinate level classification of all sorts of objects. It's just that faces are a universal example of this. You put up a face of somebody and you say, "What's this?" You say, "Well, it's a face," right? But if you say, "Who's this?" You're recognizing people at a particular low-level classification. But as we become experts in anything, music, birds, cars, greebles, snowflakes, fingerprints, as we become expert, we look at the object we're classifying, and we classify it as at a relatively subordinate level of categorization. You show somebody like me who doesn't play chess very well at chessboard, and I say, "It's not chessboard," okay? You show somebody who's a really expert chess player, and they'll say, "It's the Casablanca defense queen declined," or something like that. They'll recognize exactly what the position, what the configuration of the objects is on the chessboard, and they'll recognize that object in that way. And presumably, when they do that, though nobody's run chess experts yet, there's a study, okay? Presumably, the fusiform area will light up there as well. There is another possibility that has to be said, which is that the fusiform area is programmed by evolution for face identification, but that as people become expert in other domains, the fusiform area becomes co-opted for that purpose as well. So that if you become a car expert, the fusiform area starts performing car identification the same way it performs face identification. So there's an example, I think, where you've got a combination of something that's innate, face identification, and something that's acquired through experience, car identification. That's got to be a possibility as well. Another possibility is that Gautier and Tarr just have it wrong, right? That their experiments, however carefully they pay attention to levels of categorization, are also methodologically flawed. And in fact, there is a confound in these studies that it took people a while to recognize. And it turns out that the expertise studies of the sort that Gautier and Tarr used employed fMRI technology that was relatively insensitive. These magnets are rated in terms of their strength, 1.5 Tesla, 3 Tesla, 4 Tesla. That's the standard resolution in these kinds of experiments. And the argument was that the true fusiform face area is revealed when you use high-resolution fMRI imaging, the kind of thing you get from, say, a 6 Tesla or 7 Tesla magnet. So what happened was the expertise studies all used relatively low resolution magnets. The people who were claiming for a dedicated fusiform face area were using high-resolution magnets. And the criticism was, if you use high-resolution magnets, you'd see that there really is a fusiform face area after all, and that non-faces are processed somewhere else nearby, but not in the fusiform area itself. You can't identify that with the low spatial resolution that comes with using a low-powered magnet. There's a study that, in fact, has been done by Randall McGugan, and that's Isabelle Gautier right there. That's her student, Randall McGugan, in an experiment that presented subjects with faces, animals, cars, planes, and these are the control scrambled stimuli, to people who were at different levels of expertise. Now, what they chose, the thing you could find most easily on the Vanderbilt campus, were car experts. Okay, and that's probably true on this campus as well. But what they then did was to rerun the experiment in a high-resolution fMRI the machine, the 7T magnet, and just do it all over again to see if, in fact, it's the case that when you look at the brain activations at the highest resolution possible, you can identify particular areas that are responsive only to faces. That would be the specific fusiform face area, and specific areas that are responsive to non-faces. I wouldn't be telling, well, I'd be telling you this anyway, but the answer is no, you can't. Okay, so here's what they did. When the subjects were run, they had these subjects who were buried in their expertise with identifying the cars, and were asked to perform a matching task. They show two views of a person's face and ask them if it's the same person, or they show two views of an automobile and ask them if it's the same make and model. Okay, that's the matching task. And to make a long story short, overlapping areas of the fusiform gyrus are activated when people make face identification judgments and when experts make car identification judgments, even at very high levels of spatial resolution. So one of the tricks in the previous high-resolution studies is they didn't use experts. Okay, here McGugan has completely controlled everything. We're using high resolution, we're controlling the level of categorization, we're doing everything we're supposed to do, and the general finding here is that there is more or less complete overlap between regions that are sensitive to faces and regions that are sensitive to other kinds of objects, okay? Even in the purported fusiform face area. So what you're seeing here is essentially the correlation between identifying faces and identifying non-faces in the same region of the brain. So it's probably, let's just do this right now. Okay, the bottom line is when you don't consider expertise or you don't do high-resolution scanning, you get different areas. When you consider expertise and you do high-resolution scanning, you get overlapping areas. The fusiform face area is not dedicated to faces, apparently. It is dedicated to subordinate levels of categorization, of which faces are just the best example. Okay, we'll look at development next time. Thank you very much.